Imagine flicking on the lights in a vast cosmic auditorium, pulling back the curtain of gas and dust, and, from our VIP box called Earth, watching the grand performance of our solar system. We're a tiny audience before a scene that's been playing for nearly 4.6 billion years. But we're also the first form of life we know of capable of taking it all in, describing every character and recording the plot twists of a show that started long before we existed. Today, you and I will walk this stage in detail, from the front row bathed in the sun's spotlights to the deep blue curtains at the edge past Neptune, where the lights dim and human curiosity shines even brighter. Along the way, we'll find out why Mercury shrinks, Venus broils, Earth pulses, Mars intrigues, Jupiter roars, Saturn parades, Uranus tilts, and Neptune whispers. We'll talk about renegade dwarfs, wandering rocks, icy flames, and stardust. And remember that, even after all this, there's more universe than any imagination can hold. If this video sparked your inner fire, hit like, subscribe to the channel, and join me on this odyssey that will change the way you see the sky. The orchestra leader, our sun. Every story starts with the maestro, the star that sets the rhythm. The sun. Almost 1 million Earths could fit inside it, but huge numbers don't capture its true power. Picture a nuclear furnace where 600 million tons of hydrogen turn into helium every second. The lost mass converts into pure energy, pumped out as light and heat. This furnace has been shining for 4.56 billion years in the Orion arm of the Milky Way, and it'll likely keep glowing for another 5 billion before swelling into a red giant and swallowing the inner planets. Calling it an ordinary star sounds modest, but life on Earth relies on its exact balance of stability, distance, and brightness. Without that balance, there'd be no liquid oceans, no photosynthesis, no breathable atmosphere, and no food chains to support our civilization. The crowd divides: inner worlds and outer worlds. Right up front are the inner planets: Mercury, Venus, Earth, and Mars. They're small, dense, full of iron and silicates, forged in the hottest part of the original nebula. Behind them, separated by a debris field called the asteroid belt, we find the outer giants: Jupiter, Saturn, Uranus, and Neptune. Out there, it got cold enough for ice of water, ammonia, and methane to settle, building massive spheres of gas, rock, and supercritical fluid. One key detail: the farther a planet formed from the sun, the more ice it could gather, and the slower it orbits. Each circuit around the sun tells a story of deep time, reminding us that our one-year calendar is just a modest beat in the cosmic symphony. Mercury, the tiny metal sphere. Let's start our tour in Mercury's relentless heat. Just a bit bigger than 1/3 of Earth, with a surprisingly large iron core, this world swings between 430 degrees Celsius in full sun and negative 180 degrees Celsius on the night side. No thick atmosphere to hold heat means its cratered landscape looks a lot like the moon. But Mercury holds secrets. Long geological faults and scarps show it has stretched and shrunk. Ice deposits linger in shaded polar craters, and even its weak magnetic field puzzles scientists on such a small world. Zooming around the sun, Mercury reaches speeds up to 170,000 kilometers per hour at perihelion, fast enough to finish a year in 88 Earth days, yet slow enough that one solar day lasts 176 Earth days. If you landed at dawn, you'd see 2 sunrises every 3 Mercury years, and you'd need welding goggles and a thermal suit at the same time. Venus, the planet in a furnace. At first glance, Venus looks like Earth's twin, almost the same size and mass. In reality, it's our infernal opposite. When the nebula collapsed, Venus locked away massive amounts of carbon dioxide without ever forming oceans to trap it. The result? A runaway greenhouse effect. Surface pressure 90 times Earth's, and temperatures around 470 degrees Celsius. Hot enough to melt lead, tin, or any unshielded probe. Its clouds are droplets of sulfuric acid whipped by supersonic winds that circle the planet in 4 days, while the rocky globe itself turns so slowly that one Venus day, 243 Earth days, outlasts its year. with a backward spin no less. Venus reminds us that similar worlds can evolve in wildly different directions, and that climate swings can lock a planet into permanent unlivability. Earth, the breathing oasis. You know where we are, but maybe you haven't thought about how unique our home really is. Earth spins fast, 24 hours, to spread heat, holds an atmosphere rich in nitrogen and oxygen, has tectonic plates cycling minerals, hosts oceans that moderate temperature, and sports a magnetic field that deflects deadly radiation. All that creates a narrow sweet spot, warm enough for liquid water, cool enough to keep it from boiling away. The moon, our faithful companion born of a colossal ancient impact, stabilizes Earth's tilt, drives tides, and inspires poets. It's easy to overlook the cosmic luck that put us here. Every geology textbook and every biodiversity photo is a footnote in the biography of a living planet that reinvents itself with each eruption, ice age, or asteroid hit. Mars, the dry laboratory of hope. Mars, the red planet, is smaller than Earth, but has the solar system's best marketing pitch. Hints of past life, a future human outpost, epic canyons, and Olympus Mons. The tallest volcano around, 3 times Everest's height and sprawling like all of Poland. Today, its atmosphere is under 1% as dense as Earth's and 95% CO2, so it can't hold heat. Without a magnetic shield, the solar wind slowly strips away what's left. Still, fossil river sediments, hydrated minerals, and ice caps tell us Mars once had rivers, lakes, maybe even a northern sea. Were there microbes here? Echoes with every drill of curiosity and perseverance. If we ever settle another world, Mars has perks. A day of 24 hours 40 minutes, 38% Earth gravity, and ice resources for water and fuel. But can we terraform it? Not before we fully understand how life interacts with a world that lost its magnetic armor. The debris trench, the asteroid belt. Before we reach the gas giants, we cross a desert of rocks that never became a planet, the asteroid belt between Mars and Jupiter. Here lives Ceres, the largest asteroid and first dwarf planet, about 1,000 kilometers across, with an icy crust and possibly a salty ocean beneath. Jupiter's gravity stirred up this zone, keeping it from clumping into a full world. Each asteroid is a time capsule, preserving primordial minerals that tell the solar system's origin story. Jupiter, the giant guardian and threat. If the solar system were a family, Jupiter would be the giant father who protects but can also crush. With a mass 2.5 times that of all other planets combined, it shapes orbits, snags comets, and sometimes flings rocks our way. Its striped atmosphere spins at insane speeds and hosts the Great Red Spot, a storm raging for at least 350 years, with winds up to 600 kilometers per hour. Beneath the clouds, hydrogen shifts from gas to liquid to metallic, conducting electricity and creating the biggest planetary magnetic field around. Jupiter's 4 Galilean moons form a mini-system. Io's sulfur volcanoes tower higher than Everest. Europa hides a global ocean under ice. Ganymede is bigger than Mercury with its own magnetic field. And Callisto, crater-covered, still hints at subsurface water. Each moon is a future hotspot for astrobiology or mining. Saturn, the ringed ballet. If Jupiter is raw power, Saturn is grace. Its rings, ice and rock disks, span hundreds of thousands of kilometers but are only meters thick. Particles collide and shimmer, guided by shepherd moons like Prometheus and Pandora. Saturn spins in 10 hours 40 minutes and flattens at the poles, less dense than water. Its moons add surprises. Titan holds a thicker atmosphere than Earth's with liquid methane lakes. Enceladus shoots salty water geysers, proof of a warm subsurface ocean. Mimas, with its Herschel crater, looks like the Death Star. Exploring Saturn means decades of in-depth study, as Cassini-Huygens showed us. Uranus, the sleeping ice giant on its side. Uranus is a world of ice, a mix of water, ammonia, and methane under high pressure. More puzzling is its tilt, 98 degrees, so it spins almost on its side, probably from a giant impact early on. That gives it seasons lasting 21 years each, plunging entire hemispheres into darkness. Uranus looks calm, but its magnetic field is shifted and tilted, hinting at complex inner flows. Discovered in the 18th century, its rings are dark and slim, likely rich in carbon. Its 27 moons, named for Shakespeare and Pope, include Miranda with patchwork faults, Ariel with canyons rivaling Valles Marineris, and Oberon, where impacts reveal bright ice under dark rubble. Since Voyager 2's flyby in 1986, Uranus remains one of the least explored giants, waiting for a dedicated mission. Neptune, the lord of distant winds. At 4.5 billion kilometers from the Sun, Neptune is a turquoise sea of supersonic clouds. Winds reach 2,000 kilometers per hour, whipping up storms that come and go between Voyager 2 and Hubble visits. It leaks more internal heat than it gets from the Sun, maybe from a hot rocky core under oceans of warm ice. Its rings are faint, but Triton, a captured Kuiper Belt object, is a showstopper. A backward orbit, a pink nitrogen ice surface, black ice geysers, and hints of an underground ocean. In 3.6 billion years, Triton will cross Neptune's Roche limit and break apart into a new ring system. Until then, studying it could unlock secrets of ocean worlds and maybe, just maybe, extraterrestrial microbes. The blurred border, dwarf planets. Beyond Neptune, space isn't empty. The Kuiper Belt is a frozen highway packed with trillions of small bodies. Pluto, Eris, Makemake, and Haumea, all dwarf planets because they haven't cleared their orbits. Pluto, downgraded in 2006, is smaller than our moon, but shows nitrogen glaciers, water ice mountains, and a thin seasonal atmosphere. Eris outmasses Pluto and drifts 3 times farther out. Makemake and Haumea, rugby ball shaped with their own rings, round out the quartet. Closer in, Ceres rules the asteroid belt. Dawn's mission revealed salty cryovolcanoes active just a few million years ago, a blink in geological time. The smaller pieces: asteroids, comets, centaurs, and meteoroids. Asteroids are rocky leftovers that never formed a planet. Some, like Vesta, show internal layering. Others, like Ryugu and Bennu, are rubble piles held by gravity. Comets, ice, rock, and dust live in the Oort cloud and Kuiper belt, but sometimes dive into the inner system, sprouting spectacular tails. Centaurs, hybrids between Jupiter and Neptune, behave like both asteroids and comets. Meteoroids range from grain size to rocks tens of meters wide, burning up as meteors in our atmosphere. And if they survive to the ground, they become meteorites, prized collectors' items and vital clues to the solar system's chemistry. What it means for us. Telling this story isn't just listing fun facts. It's a reminder that every floating rock, every ring, every storm teaches us about physics, chemistry, and the chances of life elsewhere. Missions like Voyager, Cassini, New Horizons, and Perseverance aren't wasteful. They're investments in knowledge, technology, and inspiration. And it's admitting that all our survival bets lie on Earth. While we dream of Martian colonies, we must protect the oasis we already have. Understanding the solar system shows us the delicate balance that allows life and our duty to safeguard it. Did you know the nearest star system, Alpha Centauri, is 4.3 light-years away? That Proxima Centauri, our closest neighbor, may host a potentially habitable planet? Those distances feel overwhelming. But remember that in just 1 century, we went from wooden airplanes to Voyager cruising interstellar space. What could another century of innovation bring? Fusion drives? Laser sails? Chip-sized probes flying at 20% the speed of light? Every new telescope, every rocket test, every student inspired brings us closer to the answer. Closing and call to action. And so, as the curtain falls and the spotlight lifts to a new dawn, you return with something more valuable than a ticket, a lifetime backstage pass to the solar system. Now you see the scenes where Mercury shrinks like an actor changing costumes. Venus plays out a scorching drama under corrosive clouds. Earth hums in harmony with its living audience. Mars rehearses its comeback. Jupiter thunders with operatic storms. Saturn glides on its ring runway. Uranus spins sideways like an eccentric dancer. and Neptune choreographs supersonic winds on a deep blue stage. Each world, so different in tone and texture, is a key act in a cosmic story we're still learning to read. If this whirlwind tour left you with more questions than answers, celebrate. That wonder fuels science. Doubt sparks hypotheses, space missions, giant telescopes, and sleepless nights for programmers and engineers. Turn that spark into conversation. Tell us in the comments which planet or moon caught your attention. What mystery, from hidden oceans to eternal storms, you'd like us to unpack in an upcoming video. Who knows? Your curiosity might inspire our next script. And since shared knowledge multiplies, why not spread this video to fellow skygazers? Like, share, and subscribe, because the journey doesn't end here. On the horizon are new episodes, deep dives into Jupiter's ocean moons, ring expeditions to Saturn, dwarf planet enigmas in the Kuiper Belt, and even bold plans to cross the heliosphere. Fasten your seatbelt, keep your eyes on the stars, and remember, as long as questions remain unanswered, there'll always be more universe to explore, and we'll be right here, uncovering each chapter alongside you. I'm leaving you with 3 more video ideas to keep your voyage going. Thanks for watching, and see you next time.